Welcome, everyone. Thank you for joining the webcast glTF Tools from Khronos. As a reminder, all attendees are on mute. If you have any questions, please submit them via the chat feature, and we will address as many during the Q&A session at the end of the presentation. Our presenter today is Norbert Nopper, Managing Director of UX3D. Norbert?
Thank you. Hello, everybody, to the Khronos webinar about open source and free tools for glTF from Khronos. First, I'll give a little bit introduction about myself, and then I want to provide you a motivation about why we have these tools and what purpose are they. And then I go, and that's the main sections, go into the tools from the Khronos group. I will probably, or I will not have the time to have, or to introduce all of them because there are many of them. And it will be a mixture of slides and a live session. So I will use Blender to show you stuff, and I use the glTF sample viewer. And I try to explain it as slow and best possible. And finally, I do a summary where I will compare like the effort or like the output of everything. And in the end, as usual in these webinars, we will have questions. You will have questions, and I hope I can provide the answers. I think the webinar will take approximately like 40 minutes. Let's see how fast or how good we proceed. And there's a lot of buffer for questions. And like Jeff said, you can chat them and he will pick them and provide it to me. And yeah, we'll try to answer them. Okay, to myself, I'm doing this webinar on behalf of Khronos, but I'm working at UX3D. We're based in Munich, Germany, and there I'm the managing director. And if you look at the social medias, I have a lot of alter egos. So these are like my profiles at LinkedIn or Twitter, or like when I'm doing some presentations, I use all of this pickle stuff. My background is I'm a computer scientist, and I did quite a lot of stuff with OpenGL. I worked some bit on Vulkan, and of course, that's the reason I'm doing this glTF. I've worked with glTF, and like what's driving me is like I'm interested in GPU technology. Of course, a lot of stuff in real-time rendering. So I was working in more than 2 years on glTF with the 3D Formats group. The 3D Formats group is the group at Khronos which is taking care about glTF, and what you hear about is actually the thought of the 3D Formats group and the Khronos group, and not just of myself. So what's the motivation? I have a pointer, so let me turn it on. So is to the left, I have picked like a ray traced image from NVIDIA, and this is the way, for example, how you visualize or you make movies or you make commercials, etc. And typically you use Video Max, you're using Maya, Cinema 4D, and also like open source tools like Blender. And now the goal is like, yeah, I want to render it in real time using glTF. And here's just an example table from Sketchfab. I used it for purpose that like on the left you have like this high quality rendering with a sofa and so on. And to the right, you see a table. It's well rendered, but you have little shadows, and yeah, it's nice render, but it's not so easy to get from this point to this point. And so that's a challenge from the offline rendering, which I call this, or it's quite common, which is like ray path traced images or movies. And in general, if you're using these tools below there, it's not complete, of course. You have complex materials. In general, like you have a node graph where you can click together your materials. And also in general, you have high DLT, you have high polygon models. And now you want to come to the real-time rendering. Real-time rendering, from my understanding, is like you're in the milliseconds time, which is like typical for computer games or real interactive applications. And in general, you have now a rasterizer. Of course, like real-time ray tracing is possible today as well, but in general, like most of application use still a rasterizer, and then the materials are baked. And also like you have low polygon models, whatever this means nowadays. Like 10 or 20 years ago, you had of course a much lesser budget, but today you have much higher budget. But in general, you cannot use millions of polygons in your application. Sooner or later, like your desktop PC and later your mobile phone will slow down. The motivation is to bring more like use cases. So basically, you have like these digital content creation tools, which are like 3D Studio Max, Maya, Cinema, Video, Blender, what I already mentioned. And now you want to provide it to your real-time engines. And of glTF started like the most users were like in the web space, so people from 3GS. 3GS is supporting glTF, Babylon GS is supporting it, and Filament, but that's not browser-based, so it's also like it's for Android mobile phones, and you can also use it in Unity and of course like in our engine from my company. And the nice thing is that Khronos provides free and open source tools. Sooner or later, you like to get from this point to this point, of course, there will be a lot of companies providing commercial tools and with support, etc. But Khronos is providing a lot of free and open source tools that people can understand what's basically happening to get from this side to this side. They are free and open source, and everybody is encouraged to enhance the tools and to make them better and so on. And that's the purpose, like Khronos is implementing this and also providing them. So I have cherry-picked some of the main, or that's from my point of view, important tools. Of course, there are much more. So I will start with the glTF Blender, glTF.io, which is basically importer and exporter for Blender. Blender is a tool for creating assets like Maya or 3ds Max. Most of you probably know it. And the nice thing is, since version 2.8, this import and exporter is included there. Though you don't have to install anything, it's so great that it's included in Blender. You can just use it right off the box. The GitHub repository above is like the current development. So if there's a bug or like enhancement regarding speed or new features, you find them there. There's also like an introduction how to install it beside if there's already installed one there. Then I will talk about the glTF Sample Viewer. The glTF Sample Viewer is a web-based application. It's using WebGL 2.0 and 1.0 was the older one, and it's basically a simple, small renderer for glTF 2.0. And we have two repositories. The one is the one which is stable, which probably most of you know, and the second one is a branch where we currently work on PBR Next. We're also doing bug fixes there, and last but not least, it also supports KTX2. If you've never heard about it, KTX2 is a file format from Khronos as well. The nice thing it supports like arrays, cube maps and MIP maps, and also it's possible to have a compression it, and also like important is that there's a new basis compression. I will not talk about basis today, but it also supports basis compression as well. Then we have a glTF EBL sampler. It's for image-based lighting. This tool is for pre-filtering images for doing environment lighting. I will talk later about this because it needs bigger explanation. Then there's a glTF validator, where you can validate your glTF files, and there are much more. So go to the GitHub repository from the Khronos group and look for glTF projects. So you feel much more like you can auto-generate assets and so on. So for this webinar, I just cherry-picked a few of them. Okay, so let's make it very simple. So I want to bring something from Blender to the sample viewer, and I want to use the Khronos tools. And so I will start with Blender. So now let's see if it works out. I will now switch to Blender. And what I will do in this live session is I want to import a glTF or an objects file, otherwise sign it, and assign materials. I will use the camera, I will use a light, and also with use the punctual lighting. And I just recognize that there's a issue that regarding the light power, it's not doing what it should do, but we can fix this. We do going about environment lighting. And last but not least, we will export this. So let's switch to Blender. Okay, so basically, this is Blender. Blender is not from Khronos, of course. It's a free tool. And this is Blender 2.81. And normally you see here like your view. And what I'm doing, I'm now just deleting this cube because I don't want to use it. And if you go to File, Import, and as I mentioned, now you see like you can import glTF files. You see GLB and glTF. The difference between GLB and glTF is like GLB, everything is like textures and every resources is packed into one file. So it's like glTF binary. And in glTF, it's like you have everything separated where you have a separate JSON, a glTF file, you have a binary file and the textures. So we can open and import both. So let's go there. Of course, I preferred something. Let's import this glTF file. And now what you see is Suzanne I have prepared there. I didn't create here. And if I switch now to the shading, you see, and let's go to the shading mode. You see what's happening is in the glTF file, the importer, what it did, it automatically generated the shader node graph inside Blender. And the nice thing is it's using the principled BSDF, which has more. This principle has at this point of time more features than glTF. But with PBR Next, which is coming with in the coming month, we will catch up on this. So you have these nice nodes, and if you have the real shading, and now I would like to say, okay, I want to change something. And I would like, instead of a background color, I would like to have an environment texture. Now everything goes pink because I have not chosen it. And here I have downloaded an HDR file, which is like for high dynamic range rendering. Now it's loading it, yeah. And now what you see is that the reflection and the lighting is happening on this chord. And what I would like to achieve now is that we have the same result, which you see here, yeah? The same result, which we have here, I would like to achieve in the sample viewer. And I have, of course, prepared something, otherwise we're out of time. So here we have this asset. And to show somehow you, let's switch off. I would like to show you like to change materials. So we have this example model, which is like this dark skin. And the other thing is I would like to change the color or like the material. And use another base color. And now I get it blue. And let's take another metallic roughness. And here we go. We have a different looking Suzanne. So what I actually did right now is I'm using Blender, and it's still I'm in the Blender context, but I'm manipulating this node graph with the principled node with glTF textures and material settings. If you're doing this, here you have the base color, which is finally changing your main color. And here you have to take care that you're in the right color space. And generally you have a PNG file or a JPEG, and then this is correct sRGB. But here you have to change something. This is Suzanne is a metallic roughness, which is basically changing how metallic or non-metallic the value is. So here you have to change that to linear. and you just recognize you have a significant slow or a small change regarding the look and feel, but that's important regarding the interpretation. One more thing is, let's go here. We now have like a camera. Let's look through. This is where we look through. Go back to shading. And also what we have is, we have here a point light. Okay. So this is actually the scene which I would like to export and test in the sample viewer. So let's try now to export this. So I have this file, and I go here to export, and I go into glTF, and now there's the typical export dialog popping up, and here you can choose the format, and here you can by default it's GLB, but I would like to switch to glTF binning textures because I would like maybe later to manipulate my glTF file or not. So I can switch here. And what's also important that's not happening by default is you have to export the cameras, otherwise the cameras are not exported. And also you have to click puncture lights that the puncture lights are exported. So let's look for a nice place. So I put it in here, though there's the session. I export the glTF. Let's see if I've done right. And I call it my Susan. And is it, yeah, I think it's, don't need it. So quite fast. So let's see if it's there. No, it's not there. Ah, no, there it is. It took some time. Yeah, so here it is. And let's see where we are. Okay, so next thing is I have exported the file and now I would like to validate it, because sometimes, because you're here from here to here, you're exporting something, and in the best case your exporter is super good and it's doing everything fine, but in some cases it can happen maybe the exporter does not understand a setting in your Blender or 3ds Max or whatever, and it's also a very good thing to validate it. So you can manually inspect this, and I will now go to this web page. So let me go back. So I go to the repository, and there's a tool where you can live by drag and drop, where you can say, no, I would like to validate my file. So I go there, I take my Suzanne, and I put it there. And yeah, nice thing is it's valid. Yeah, so the people who implemented or supporting this glTF it's valid. The nice thing is you already see it's already using a punctual extension, and you probably already get the feeling that the environment light is not exported, but that's because that's not supported at this point of time. So, but this validator is great. You can see like you have no errors, you have no warnings, and if you have errors or warnings, they pop up, and again you can fix it. Either you can fix it manually, which is possible, but also like give a report to the people who implement it. So go back. So next thing is, now I would like to see my asset in the sample viewer. So let's open it. I have two versions of the sample viewer here. This is the one you normally know. This is the stable one. I'm using the work in progress one because it has some bug fixes, and also it's supporting the KTX2 file, which I will later use. So normally when you start, this is your sample viewer. It's a web-based application, and what you see there you have a big screen where you have in the middle a glTF asset. You can rotate it by drag and dragging, and to the right you have a menu, and I would like to explain you in short what this does. So in general, this glTF sample viewer is here that you can watch glTF files. Yeah, and here you have a drop-down list where you can choose between a lot of models. And let's take another one. Let's say, for example, the flight helmet. Here we go. And the next thing is glTF version is 2.0. At this point of time, it's not changing, but maybe sooner or later, there's glTF 2.1 or whatever version, and you will see it here. This viewer is not supporting glTF 1.0. Then a scene index, glTF can have more than one scenes. In general, most glTFs only have one scene, though this is most the same. And as you see here, you have the orbit camera. This is, for example, this. Let's take another model. I think the duck, it has a built-in camera, and then you can choose it, and it doesn't work. Okay, for what reason? But let's go there. Good. Okay, then animation. There we need something with a cube. I have an animated cube. So it's a basic animation controller where you can see, there's a cube, nothing special with PBR materials, but here you can inspect, okay, the animation is working not. Because this is a live session and all the stuff is transferred over the internet and is captured from my screen, the animation is probably a little bit, I think the English word is choppy. It's like, it's not fluid, but if you look at in real time on your PC, it's smooth. So here you can play and stop it, and if you have several animation, you can choose. The most important thing, and this is what I would like focus on, is about the lighting. There are several settings, and actually I want to only talk about the top two. The other one are like going into deep where I can like say, I want to make it brighter or whatever. Yeah. And you can do a different tone mapping and background like this. But what's also important is, let's take a different model where you see it better. Flight helmet. The models are lighted because of the environment what is used. And here at the bottom you see like it's currently using courtyards of the dot. That's the environment map. But for example, if I'm taking another environment map which is now loading, and now look at the screen, like the appearance is different. For example, if I'm turning off image-based lighting, the whole model gets black. It's like you're simulating like a pure, perfect dark screen. So I turn it on, then you have the light. And there's another option which is called puncture light, which is the default puncture light included in the sample viewer. At this point of time, you cannot manipulate it. But you see the difference. If this puncture light, the light comes from the upper right to the bottom down, and you see at this side you have it's almost dark, and if I switch to the other one, you have a environment light, like all around the model you have light, and of course you can mix it. If the glTF file contains a puncture light, the included puncture light is deactivated, and after it is deactivated, the puncture lights included in the glTF files are used. Okay. And last but not least, you can debug the scene. So you see like you have metallic channels. Because the glTF file, let's go back. Like this glTF file is physically based, and as the materials are based, it has several channels, and all the channels are baked into different channels, the textures and the variables. And if you would like to inspect it, how this picture comes up, you can here go into like a debug mode where you can say what are the channels that this image appears. So if you go into base color, you'd see just like the base color of this model, which is flat because it's not lighted. But you see, okay, now you see what is flat and what is not flat. And the next thing is you can see which is metallic in your 3D model, and everything what is black is a dielectric, is like what plastics are, but everything what is white, it's like a mask, or it's like a scaling factor, is what is metallic is. And you see here is like you have a mixture of gray. There we can like you can make rust or scratches into your metal. And also like you have a roughness map where you can say how rough your materials are. And yeah, you can go to the normals, which are like how your model looks like, so on and so on. Occlusion map to have like pre-baked shadows. And all these channels together and with the lighting is generating this nice image. Okay, I think I shortly explained what the sample viewer is doing, and now let's drag and drop my model in here. And what you see, it's because of the color light. I take this off because this is what I said, what you just experienced. The light in here is exported too bright. So in Blender 2.7.9, it was like it was calculated correctly. This was somehow lost. So if you would like to have this more or less the same effect, you have to go like this to 1, and then you get like a similar effect. So let me close this application because I have prepared it. I exported before. So I have made this fix manually, and I have like here my Suzanne. Now I would like to, this is the black Suzanne, what I have. Like this is the one I showed you first. And the second one is here. And now here, I cleaned up the light. Yeah, and if I go now to full screen and I put on the light and I go to the correct camera, you look here, and now you see, I don't know, I hope you can see it as well. You see a reflection, and of course, this is not the environment which I used. Yeah. And if you would like a perfect lighting, this is a problem. And yeah, now I would like to compare it, and let's open it. So if you compare this shading and you see reflection, you see here a forest, and you see not a forest, but you see like a city line, and that's a no-go. Maybe for some people say, hey, this looks the same, but if you really go into detail, it doesn't look the same, and we'll later make a comparison. Okay, let's go back. And the problem is, well, it's not a problem, it's just a feature which has to be implemented. If you just take this light, you see it more brighter that you see here the city. And if you have the puncture light, this is more or less, it's okay. Okay, so let's close this and go back to the presentation. So if you compare like the images between your renderer, like with puncture lights, if you tweak the values correct, you get like to 99% the identical output. But with our environment light, of course not, because the sample viewer doesn't have your environment for rendering at this point of that. It has the one which are included, but when you're doing like your own 3D scene, maybe you want to use a special one. And that's where the IBL sampler comes into account. IBL sampler is for image-based lighting. It's a new tool. It's a work in progress, and the tool is there that like all the people who are using glTF, they can more or less somehow exchange the environments for lighting to each other, like pre-filtered. To make it short, what it does, and this is what I showed, is let's take the pen again. It's like you can really basically, of course, like lighting is really sophisticated, but let's take the main two lighting methods. Let's say you have the puncture lighting where you have a light from one direction. This is what you saw in the sample viewer, where like to the left, the light is coming from here down. To the left, you don't have light, but you have here these nice reflections and so on. This is like already working, and it's already standardized, and it's working out of the box with glTF. The other one is image-based lighting. Of course, it's working here as well, but at this point of time, there's no possibility to exchange these lighting settings. And this is what the IBL sampler is for, where you can say, I have an environment map, I can pre-filter everything, and I can provide it to another engine, and this engine can read it, and they have, if they interpret the data correctly, the same rendering output. So what is here? So let's go back to say what environment I used. Actually, let's open this with GIMP. This is the environment. It's a panorama image, and I have taken it from the internet, and I would like to use this environment for lighting. I already did it in Blender, but because Blender can interpret it and it's integrated out of the box, and I just edit it and it's working. But now I would like to use the same image in my engine, and what I need is for real time, it has to be pre-filtered. When you have an offline renderer, normally you have a frame to generate or render a frame. You have maybe seconds or even minutes to render a frame, and then you have these ray trace and path trace, and what they are doing, they are filtering. They are filtering this environment. Like you say, okay, you have a diffuse light, and then the ray goes into every direction. And this is what a path tracer and a ray tracer does. It can really do this directly. Or if you have a spectral effect, you have a special lobe, and then you can sample it like this. But for real time, it's not possible because it's too slow. And that's the reason why you have to pre-filter this stuff. And if you pre-filter these images, I have generated one to the right. It's just a layer. They look like this. You have to pre-filter them. The quality goes like, it's almost the same, but of course you have some trade-offs. But this is what eBay Sampler does. It is generating these files for you. So what is this sample doing? It's generating at this point of time, and in the future more. It's generating a diffuse map for you. It's generating a specular map for you, and if wanted, you can also have a lookup table. This is not directly related to glTF, but this is required for your engine in the background. Like your glTF file, at this point of time, it has a mesh and it has a material, but your engine needs somehow the information for lighting. And actually, what you see here, if your engine is supporting it, KTX2, and wants to have these pre-filtered images, it's they can be generated with this. Okay, next slide. So what I will do now, the tool what we have is it's a command line interface, and what I generated is you can provide a panorama image, and you can generate a cube map out of it. It has several settings. You can go to the GitHub repository and download it. At this point of time, it's generate RGB and floating point. This 16 and 32 bits. In the future, it will also support compressed data. So to execute it is, I would like first to do the Lambertian one, which is like the diffuse part, and I just execute it. And now it's generating here me a KTX file, which should be here. This is my KTX file. Now I take an image editor to open it. And this is what is generated. So this is the cube map. This is like the top, bottom, left, right, front, and back. And it pre-filtered it. And here you can inspect. The reason why it's so blurry, because it's the diffuse part, and it's you have to read the papers to fully understand it. But this is like the data what your engine requires. So this is like the diffuse part. And now I would like to generate KTX2 file for the specular part. And it has now more parameters where you say I want to have which distribution. It's GGX, which is the one for specular we use in glTF. Then you can say how many MIP levels you want to have here. You can optimize. And also like if you would like to bias this everything. So let's start this. And now it generated me the KTX2 file, and it has overwritten the previous one. And I open it again. And the funny thing is, it looks like now, wow, this looks almost like the environment map just as a cube map. In a specular map, you have several informations stored. Like this is the information if you have a pure metal or like a mirror material. And if you're going down, this is when your material is going rougher and rougher. For example, you have a metallic which is rough, and then like the distribution changes, and then it goes blurrier and blurrier. and on. And this is, and now this is actually the data what you can feed, what you can put into your engine. So either when you're using Unity, or if you're using Unreal Engine, or like you're using Babylon JS, whatever, this what I just did is normally happening in the background. But the problem is now, for example, I would like to have an environment map from Babylon JS, and I would like to run it in our engine, or vice versa. There has to be somehow specified how these pre-filtered images look like. And actually, this is the effort what we're currently working on. It's not finalized yet, and there's still a big discussion what should be ratified or not. And yeah, so stay tuned what's going on with this. Okay. So we're like, it's 1817 now. The point is, now I have this KTX file, and now the question is, how do I get this together? And I have, of course, prepared everything. These are the same files. What before this is like the Suzanne glTF file, it's the binary file, and these two files are like the information how metallic roughness this material is and what the base color is. And here to the left, they are now these pre-filtered images, and I would like to use them in my tool in the sample viewer. So what you do have to do it at this point of time, and in the hope in the future this can be automated, but you add, like, you say I would like to have an image-based lighting extension. You add it. At this point, it's not ratified. I'm not quite sure it will change. So this is going to change. And then you can say what this light is. So it has a diffuse part. It has a specular part. And then the scene is using an image-based light. And then the rest is like before. You have to say, okay, here I have images. And here's my libration part. Here's my specular part. And then you have the textures, the samplers here, and you have the textures, and basically this is fitting together. So you have here the images, which are like the mapped cube maps, and then you have the textures, and then you have the samplers, which is still more or less the same what you know with a normal glTF file. And then you have here the image-based light, where you say, I want to have an image-based light which is using these textures. Okay. So what I will do now, I will start again my PBR Next sample viewer. And now what I will do is take this and drag and drop it in here. So what's happening right now is now I can view, so this is the black one where you maybe don't see a bigger difference, but now I take the one here. And now if you look at the detail, it's not the skyline. If you go here, it's not the skyline anymore. Now it's really the environment map from here. Yeah, so I'm now using this light for my lighting. Yeah, and now I turn off punctual lights and I use the camera. And if I go like this, I have actually the same point of view like what I have in Blender. Okay, so I here have the specular part. Let's do it again. So if you here see like the specular parts, it's now turned off. And if I turn on the punctual light, it's coming here from the punctual light. And I have really the image-based light from the environment, which is I'm also using the same one in Blender. And that's key to have like the same visual output, for example, in Blender and glTF. That you have, if the lighting is correct, the visual appearance of your models will behave correctly. Now it's 1814, and now let's see where we are. So these are the generated thing. I have put it in a sample viewer, what I just did. Deploying these EBL, so either you can put it on your server, and here in the live session, I just dragged and dropped it into the sample viewer. And this is what I just did. And now I'm already at the summary because I'm a little bit afraid I'm running over time, because I would like to take some time on this slide because I prepared this So to the left, these are renderings from the Blender. This is from Blender, and this is from Blender. And what I removed here, I removed the background. I also removed the background. I'm using the same background here. And to the right, you see the renderings from the sample viewer. Yeah. And on the first sight, they look identical. Like you have like these bright spots, you have here this bright spot, you have even this here. But if you look clearer, it's here a little bit brighter and it's a bit darker. But in general, on the first sight, it's more or less identical. And now like here, it appears darker and here's bright. And this is where currently the Khronos group and the 3D formats group is working on. That we can like nail down what are the factors that it's really looking identical, and we're in a good progress there. And I hope like in the coming months we have somehow defined what are like the triggers and the parameters to have the same visual output. On the mathematical side, it's clear, but the point is every engine is maybe some interpreting it a little bit different, and this is what people try to do now to get everything aligned. But if you make a step back on the first sight, you see it's like it's going to, we're over 90% now to get it identical. Yeah, it's like an expert has to see it like there's a difference. But yeah, we keep on working on the lighting, on the material system, and hope we get 99% soon. Okay, as I said, going to question and answers. So we are about now 45 minutes gone. We still have 15 minutes, so I'm open for question and answers. So I hope you guys are still there, because I get absolutely more or less no feedback. And Jeff, I hope the people are still online.
Yes,
And
we have a few questions.
And I hope you have some questions for me.
Yes. The first one's from Jing Zheng. He
Yeah.
asked, does the glTF validator store the drag model or the asset, or is the asset safe from leaking out to the public?
Either the point is it's a web application, but the point is if you drag and drop it into there, it's not transferred over the web. It's like you're putting into the browser and everything is executed locally. It's not like the application is communicating with the backend. If you really want to be sure, the best thing is you download everything and execute it locally on your PC, and then you can be sure that it's nothing happening. But I trust Alexei implemented this, and I am quite sure he's not doing anything weird. And but to say it in short, your files are safe and they are executed locally on the website.
Okay. Next one's from Igor Toromansky. Which WebGL renderer is being used by the sample viewer? Is it Babylon, 3JS?
The sample viewer itself is its own engine. It's based on WebGL 2, and it's an own implementation using JavaScript. So it's nothing. It has nothing to do with Babylon or JS or with 3GS. Babylon JS and 3GS, they are very good engine. They have a lot of features. They are powerful, and you can do quite a lot. The sample viewer is really small, and that's on the first side maybe a disadvantage, but the advantage is the purpose of the sample viewer is to understand like the shaders and the math, and the goal is to keep it really, really small. And for example, if you go into production or you want to go release something, then use Babylon JS or 3JS. If you're going for web, because they are based on the same math in the sample viewer. The sample viewer is there to synchronize between people from Babylon JS and 3JS, because we need a small source code which can be easily changed and adapted to get, say, hey, we have to change the lighting formula. Hey, we have to change this and this. And that's the purpose for the sample viewer. So to say it in short, the sample viewer is an own implementation using JavaScript, and based on WebGL, it belongs to Khronos and is completely open source.
Wonderful. Next question is from Don Carley. Is there support for spectral BRDF material descriptions and render pipelines?
At this point of like glTF, if I understand the question correctly, is separate it's the same what you see like in the Unreal Engine Unity. So it's based on it's a metallic roughness model, but also like with glTF you can do the specular glossiness workflow. Though this has so far nothing to do with glTF. There are like two main approaches how you do BRDF with real-time BRDF. So there's the metallic roughness workflow and there's the specular glossiness workflow. Basically the math behind it is the same, but there's always the need to optimize channels and that not to deploy textures. And for example, with metallic roughness, you need less information, and with specular glossiness, you have more information, but of course more texture data, for example. But in the future, you have like the diffuse part and the specular part. But in the future, we will have clear code, we will have sheen, and all these nice effects which you see in other engines as well. To say it in short, at this point of time, you have a diffuse and a specular part, and it's supporting it. And I hope I did answer your question.
Okay, another one from Don Carley. He asks, it seems that you're describing materials in terms of tri-stimulus value and a BRDF value. Does glTF support materials described in terms of spectral distribution function?
A spectral? I have no clue. I don't think so. No.
Okay. Next question from Michael Geflick. Hi, I work with Pure WebGL, No3JS, Babylon. Could you give me an advice? Should I write my own glTF rendering function, or could I use a code from the example of your glTF viewer? Do you plan to make library free API for glTF rendering?
Well, of course, it always depends what you want to achieve and what's your approach. First, like the glTF sample viewer, it's Apache 2.0 from Khronos. So regarding licensing, you can look at it and you can use the sample viewer as a base. It's open source. And of course, it's quite some work to implement the good render. And if you want to focus on an application or business, I would recommend to use 3JS or Babylon.js on the web. If you would like to implement your own for some reason, because you have a special business where you have to need your own proprietary one, I think the glTF sample viewer is a good base because it's really small and easy to understand. So if you fulfill the Apache 2.0 license, like the restrictions, go ahead, use it.
Wonderful. Next question is from Kevin Moreno. If I use your validator and viewing tools, will I be sure that will play in the technologies of the major e-commerce companies, for example, Wayfair, Shopify, Amazon?
There's this really commerce effort going on, and now I have to think a little bit because some stuff is public and some stuff is not yet public. And the glTF validator, let's say it like this, the glTF validator is like the main tool at this point of time for validating glTF files. If like these companies you mentioned are using this now as a standard or is like this is the one, I don't know, or I can't say, let's say it like this. But it's really an important tool, and as soon as it officially, you will probably know it. But as far as I know, a lot of companies out there are already using it for validating their assets.
Okay. Next question from Misho Ristov. Can we have the tone mappers both in Blender and in the sample viewer?
It's regarding this, you have a setting in, this is the way how you interpret the data. And in the sample viewer have like this linear tone mapping, and you have like the stuff what you see also in game engine, like A's and stuff like this. You have similar settings in Blender, and I think you have much more. But of course, Blender is so powerful, I think you can do it in your post process on your own. So if you have a special tone mapping, you could probably implement it in Blender. I'm not such a Blender expert, but I'm quite sure it's possible. So at this point, what I showed you, these are like the typical gamma corrections, which I showed you. And the tone mapping is at this point of time not standardized at Khronos. At this point, we say do gamma correction, but there's no extension or standard where we say, oh, there are some specific tone mapping algorithms your engine has to support. Of course, this is not 100% the answer to your question, but what I would like to say, you can do tone mapping in every engine, but it's not standardized, and it's not standardized at this point of time.
Okay. Michael Beal was wondering, what is the size of the IBL file?
Yeah, at this point of time, it's really huge. Yeah, and because it depends how you sample it. If you have a HDR file, it's normally RGB encoded. And as maybe you've seen it in the console, at this point of time, you can generate like 4-channel with 8 bits, 16 bits, or 32 bits. This is at this point of time, this is for evaluating everything. Of course, and this is maybe it was too fast at the beginning. In the future, KTX2, or it already supports, but the IBL sampler has it. You can compress it. You can use the typical compressions what your GPU can. It's so like BC6 or BC7. But the nice thing about this basis compression, which is included in KTX2, you can compress these image data really down. So at this point of time, they're like not compressed in the KTX2, they are huge. But in general, normally you should use these data on the server side. But it's possible to compress them. For example, there's a tool at Khronos, it's called the glTF Compressonator. It can load a KTX2 file, and there you can compress it, for example, to basis. And then the file gets really, really slow. Small.
And this next question is from Luca Pirabella. What about blending animation?
It's not with blending animation. I say you have a walking animation, and in parallel you have a let's say you're waving a flag or something like this, and you want to blend this. This is what your engine will do. A glTF file has what I showed you. It has most time one animation, but it can also have several animation. And the point is, glTF is a transmission format. And what you're using with this glTF file is up to you. And this means if your engine can do blending, you can blend together these animations, but it's not like standardized how this should happen. Yeah. It's like this. You have like these two animations, and of course you assume that these animations are exported in such a way that they fit together. And if your engine supports it, then you know there's animation 0 and 1. And if your engine can do blend it, it's possible, but the file itself does not have like a tag or something like this.
Okay. Next one from Xingjiang. How is transparency handled in glTF?
Yeah, with glTF at this point with the 2.0 version, glTF it's a typical alpha blending. So there's no refraction, but as I already mentioned, there's a effort for glTF PBR next. And if you go to the repository, there's an effort going on that we have like extension where you can have refractive materials. So at this point of time, the transparency is handled. It's just like a blending, like where you do alpha blending. But as soon as PBR next is out, it's possible that you have refractive transparency, that you like it's getting blurry, or you see things upside down in a lens, for example, or yeah, all these refractive.
Okay. Dan Carley asks about the color components, hyperspectral or multispectral versus color metrics tristimulus.
Yeah, regarding the spectral stuff, it's a topic where I'm currently not into it, so I cannot answer it.
All right. Let's see. One more question. Let me see. You showed Blender matching sample viewer at 90%, or other engines, Babylon, 3JS, etc., attempting to sync with the sample viewer? For example, are we hoping to reach a visual standard across the board?
Yeah, this is the thought going on. That's the reason why there's the sample viewer. It's like 3GS and Babylon.js, but also Unreal Engine and Unity. They started, they were reading the SIGGRAPH papers, and they provided the SIGGRAPH paper. They implemented it, and there's always like your little spicy stuff which makes the things a little bit look different because you're storing data differently. Nobody's doing wrong, but people did not agree yet. But that's the goal with the 3D formats code and glTF. Like with the sample viewer, people will say, hey, this is a sample implementation, and now people can exchange their asset to each other, and they, hey, I would like to have the same asset look like the same in Babylon, and it has looked the same in 3GS, and this is what's currently going on. We will probably never reach 100%, but I'm quite sure like sooner or later we will reach about 95 to 98% that the visual output is identical. So yes, this is the goal, that like if you open a PNG file, you double click in it looks the same in GIMP and Photoshop. And like on a long-term goal, I hope it will be 100%. On a short-term goal, it will be 95 to 98%, that like the same asset with the same lighting looks the same in Babylon or 3GS. Yes, that's the goal.
Great. Thank you, Norbert. We really appreciate it. Just to let everyone know, the recording will be made available on Khronos' YouTube channel, and there will be a link to the presentation within the next few days.